Hello, everyone. Hello, everyone. Good morning and good afternoon on our today's panel discussion. The topic which we'll be covering today is a multi-phase approach to developing, optimizing Omics pipelines in the cloud. And this particular session was organized together by Ardigen together with MemVerge, Amgen, AWS, and Seqera. Our today's presenters are me, Kamil Malish. I'm a lead Nextflow developer in Ardigen with a 7 years of experience in the field, currently working as a Nextflow developer. My specialty is Nextflow pipelines optimization in the cloud. And outside of Ardigen, I'm proud father of 2 kids, 2 and the 5-year-old. Passing to Ying, our second organizer.
Yep, thanks, Camille. And hi, everyone. So great to be here. My name is Jing, and I lead go-to-market for MemVerge. Outside of work, I also have two young boys, 5 years old and 2 years old. And then on the work side, I really enjoy helping people save money with sponsors. Back to you.
Thank you very much. Thank you very much, Singh, for your intro. And our guests today are Geraldine van der Aura, Ankit Malhotra, and Itai Eres. Geraldine is a lead developer advocate at Seqera. She spent 10 years at Broad Institute supporting the genomics community, authored the O'Reilly book, Genomics in the Cloud, and now at Seqera, she is responsible for nurturing and growing the Nextflow community. Thank you for joining us, Geraldine. Ankit is a global genomics lead for AWS public sector. As a trained computer cancer biologist with over 2 decades of experience in the genomics industry, he helped research healthcare and life science organizations accelerate and innovate using the cloud. And Itai is a senior scientist in computational biology and bioinformatics technologies at Amgen. Has a PhD in human genetics and been a computational biologist at Amgen for a bit over 3 years, where he plays pivotal role in enabling and executing epigenomics analysis to drive deeper understanding of target and disease biology. In his free time, Itai enjoys sharpening his strategic thinking through chess and staying active by playing soccer. So our plan for today's panel discussion is an intro, which we already partially covered. Then we will start the discussion, which will cover 3 main topics: industry challenges, optimization strategies, balance between developers' experience and business challenges. Each of these sections will cover around 15 minutes, and at the end we'll have 10 minutes of Q&A session. Industry challenges will be focused around common challenges faced when running Omics pipeline in the cloud. And optimization strategies, those will be our thoughts and ideas which we tested over past time, which allow us to be efficient and effective, especially in cloud. And the balance between developers' experience and business challenges will be focused on cost management and operational strategies and exploration in this area. So right now, let's cover a bit more into whom are Ardigen and MemVerge as a companies. So the organizers of this meeting. In Ardigen, we are proud to be recognized among 40 leaders of the global AI in drug discovery market. With almost 10 years of experience, we become one of the biggest and well-established AI CRO. Our track record is quite impressive. At least we consider that one as being impressive. We succeeded over 400 projects. We have over 400 partners in the field. We are working together with 15 big pharma companies. And when it goes to company itself, there is 180 of us, and over 25% of us are the PhD, and this is our backbone of our organization, the collective experience and expertise that fuels our success and sets us apart in the competitive landscape. And a few more words about Ardigen's, how we approach the idea. We believe that improving the likelihood of success of the drug discovery process requires biotech and pharma companies to fully leverage power of data. So we position data at the center of the any research, and the aim here is to unlock its full potential. This shapes all the structure of the modern biotech with three key layers: infrastructure, data universe, and scientific insights. And our offer is structured around these three pillars. I will not dive deeper. If you're interested in any other topics here, feel free to touch base with us. Today, during this panel discussion, we will touch only three aspects from our offer. So if you would like to hear more, feel free to touch base with us. And with that said, I will pass my voice to Ying to present MemVerge.
Great, thanks, Camille. So just a little bit about MemVerge. We are a software company based in San Jose, California. We've been in business for a few years now, and our cloud product has been in market for about a year and a half. We are experts in helping users run in the cloud more cost effectively. And one of the things that we're most well known for is some unique ways that we enable you to use spot instances. It's been a really amazing journey bringing our product to clouds like AWS. This past year, we're being used by customers in over 4 different continents. And a few months ago, we hit the million core hours metric, which was a nice little celebration for us. I won't go too much further, but I will do one more slide just to talk a little about what is that our actual solution provides and does. Thanks, Camille. Our product is called Memory Machine. It's a cloud automation platform that helps you run different types of genomics pipelines and tools. There's really two cornerstone features that help you run in cloud more cost effectively. We call them Spot Surfer and Wave Rider. Spot Surfer is basically a way for you to continue to run on Spot instances and survive the interruptions that inevitably happen, so that if you have a very long-running pipeline or analyses, you don't have to restart those workloads from the beginning. Wave Rider helps you to the true compute resource that you actually need. You're running things in the cloud. It has the ability to statefully move you to large instances or to smaller instances, so that you're not running over provision, and you're also preventing common errors like running out of memory. And we do that in a nice interface that works with others in the ecosystem as well. And if you'd like to learn more, reach out to me after the
Thank you, Ying. With that intro, let's start our panel discussion. First topic is industry challenges, and the first question which we have is, can you share an example of challenge you faced while developing an omics pipeline in a cloud environment and some lessons learned from it? And here I would like to start this discussion with you, Itai. So can you share some comments or your experience?
Definitely. Thanks, Camille, and thanks everyone for joining us today. So yeah, there was one particular pipeline that presented some significant issues for me, including an odd default run behavior, the expectation that both the input reference genome files as well as a number of scripts that get executed would exist at a particular path within the Docker container. And similarly, it was expecting to be able to write output files by default to a path, again, within the container. And so you might be able to guess, based on what I've said already, pretty much all of this can be attributed to poor Docker image creation practice, as the size of the inputs and outputs was significantly limited by the size of the mounted drive that was in place when the image was first created. So in the cloud, all these elements were very limiting. I really wanted the container to have the various pipeline scripts available without directly running them upon loading, right? I wanted to be able to load the image without necessarily having it have a default behavior of running immediately. And I also wanted it to enable me to follow a series of custom steps based on what my data needs actually are, as opposed to what the author might have thought everyone would want to use it for, right? And I also wanted to be able to use much larger input and hence also output files that much larger than the original author must have realized, since the Docker image's mounted drive was relatively small. So in the end, I directly altered this image by going into the Docker file in question, creating a new Docker file, altering the entry point, and forcing the scripts to write to a much larger, temporarily mounted Scratch storage space in the cloud. And I would say, overall, this was a pretty big headache in my experience. And what I learned from that is that you should avoid using Docker images that are not recently updated and or widely used. In this case, I didn't have a better option, unfortunately. So barring that, I would recommend that you definitely take a look at the Docker file the author used to make their image to understand how it might behave in the container instance when you actually start running it. And particularly with respect to the potential entry point, which is to say the default run behavior when the image is loaded into a container. Because again, you never know what someone may consider a reasonable practice for creation of a Docker image that actually ends up being extremely prohibitive in a cloud setting. But there is a silver lining there. I learned a lot about how Docker works from all that troubleshooting.
Thank you very much, Itai. That is very important topic to remember that, well, first in cloud, the most popular way to deploy are the Docker containers. So a robust Docker container is a very important aspect when we are developing in cloud. That's very important lesson. Thank you for this comment. And Geraldine, maybe you can be the next one whom can share some comments regarding your experience, especially in your previous position when you've been working with Genome closely.
Right. Yes, absolutely. Thank you, Camille. I would say, kind of extending from Itai's example, I've had a lot of experience with supporting use cases where we need to enable a community of researchers to use certain pipelines which come with their Docker images and so on, where the same code, the same containers need to be used both by an external community of researchers and by an internal production facility. So I'm speaking specifically in the case of, in my previous life, when I was working at the Broad Institute. The Broad has a fairly large, I think it's an understatement, genomics facility that produces a huge amount of sequencing data. I think the last numbers I remember were like the equivalent of pumping out a new whole human genome every 3 minutes. It's a huge amount of data. So you have to have a production facility that's running on a constant basis, can't have any interruptions and so on. So everything has to be engineered to be extremely robust and at the same time auditable and maintainable in a very flexible way. But at the same time, we want to be able to, make the scripts, containers, and all of that accessible and usable by the worldwide community of researchers. And so there, the kinds of trade-offs you run into are the necessity to have containers that anybody can use for a variety of use cases, but also workflows that are both optimized for the production facilities needs, for example, the ability to run at very low cost, balancing performance, so performance in terms of speed, and resource utilization. which is fairly complex, and I'm sure we'll talk a lot more about that during the panel. But balancing that with portability, because you need to be able to take those scripts and run them on different kinds of infrastructure. So at the Broad, we were using Google Cloud, but we wanted people to be able to port the pipelines to other infrastructures. It's been interesting since I've joined Seqera. I'm working with Nextflow now. The Broad was working with Whittle, WDL. There's kind of different answers to these kinds of problems, right? What it comes down to is the ability to separate, kind of have a separation of concerns between the scientific logic of the workflow and the actual engineering of the workflow, in terms of the plumbing of the various steps and how they work together. And there are certain, languages and tool sets that better supports having that separation of concerns and having that portability and reproducibility, which ultimately enables you to satisfy both, production imperatives and the need to have reproducibility and portability within the community.
Thank you very much, Geraldine, for your comment. That is also very, very important that you mentioned Nextflow and WDL. And here I may still some time to give my comment and my perspective, because I started developing the pipelines which customers envision to be deployed in cloud before Nextflow, before WDO. And first we used SunGrid engine. Don't ask why. That was one of the requirements. And later we migrated those pipelines to Nextflow. And one thing which we noticed and which we envisioned as a challenge during this migration was the actual redesign of the logic of the actual pipeline logic to support more natively cloud environment. Because, for example, parallelization in cloud is efficient in a little bit different aspects. It is better to have more smaller jobs rather than larger jobs which consume large amount of resources. So the problems like clustering, for example, which is very common problem in bioinformatics, should be solved a bit in different way. Different algorithms are needed to be efficient in cloud. So those are the challenges which we faced when we've been when we've been migrating from HPC environments where customers had beefy clusters with large CPUs, large amount of resources. They've been super happy to submit one job which was running for a few days on those all cores, versus in cloud. Well, we would like to use spot instances because they allow us to save some time. So this is something what is important to keep in mind, that your algorithm may need some modification, especially when you consider first migration to cloud, because between clouds it's not that different. But HPC versus cloud, that can be there might be important aspect it may be an important aspect to remember about long job versus lot of small jobs which will end in the same result.
Kamil, if I can just add a little bit more to it, I think it's not only about the distinction between long jobs and short jobs. I think it's a whole new different sort of set of thinking that goes into it, because now you're not limited by the resources that you have on-prem.
Yes.
Right. If you're going to the cloud, you have access to a vast array of all different kind of infrastructures, right? Like with AWS, you can get access to FPGAs, you can get access to GPUs, you can get access to high memory machines and lots of cores and high networking bandwidth, and you can get access to specialized machines instances which have Trainium and Friendship that accelerate machine learning workloads. So it's sort of a different sort of way of thinking, how you go about developing, so that you can leverage the best out of a cloud service environment. And it also allows you to sort of innovate and get at the leading edge of innovation faster, right? Because you're no longer constrained, or
Yes.
when my jobs will run, and when how quickly can I turn these things around. So it's quicker access, it's the scalability, and it's the dynamic nature of the cloud that if you're thinking of developing new pipelines, that's certainly a different way of thinking. But then,
Yeah.
I mean, as a cloud service provider, I also often talk to customers who have like legacy code that they have. Like I was just talking to somebody yesterday, and they have like code that's written using Singularity, and there's challenges that they have about updating that piece of code. And that's where, I mean, we also have stuff like parallel cluster, which provides you that HPC kind of experience in the cloud. So yeah, it's the access to all these different services and understanding that the breadth of what you have available to you is the first step to migrating to the cloud.
You're right. As long as yesterday we've been working on pipeline optimization in AWS batch, and we speed it up by 30% by simply selecting different instances which been more accurate for this particular jobs. So you're right. You can literally within seconds change all infrastructure which is used
Yeah,
by the
I mean,
pipeline.
I think everybody uses PWMM. We published a blog, I think about 2 years back now, where we just what is it, recompiled PWMM to use the ARM, our Graviton instances. And not only did it speed it up, but because Graviton, we can sort of manage the costs of the ARM instance, the Graviton instance is better. It gave you an immediate 40% reduction in costs because those instances are cheaper than your CPU instances. And that was simply just a recompile of the code to run on ARM. So it's things like these. You have to be a little bit more creative. Once again, back to the we have a breadth, a very large pool of resources that is suddenly available to you, and you get to think about it in a slightly different way.
Yes, but the challenge here, which scientists and our customers as usually are facing, is how to get this knowledge, how to become a fluent in cloud. I believe those are the parts where our expertise is very helpful here, as this group which we have here, where we already where we are past this journey, and we can share those experiences. Ing, would you like to comment on this one?
Yeah, just to add on to what you guys have shared, I think challenges are different for different people, and I think even the word optimization means different things to different groups and people as well. Some people want to optimize absolutely just for cost, like lowest cost execution if I'm going to run this in the cloud. Others would rather the jobs finish or pipelines finish as quickly as possible, and the time sensitivity to them is the most important. And others would prefer predictability and consistency in terms of being able to run X amount of analyses or pipelines each and every day. And so the fun thing about being in this space is helping customers getting to their different goals in different ways. And sometimes are the things that MemVerge is working on helps, and sometimes it doesn't necessarily help. But it's a nice experience to be part of.
Thank you very much for your comment.
That journey with them. And yeah, that's my perspective on this.
Thank you very much, Ing, for comment. Sorry for interrupting. I thought that you finished, but there was a small glitch. With that said, I think that we should move forward, and well, we probably could spend all hour in this topic, but let's at least touch other topics which we planned for today. So those are the optimization strategies, because each of us for sure encountered a issue where our pipeline either runs for days, months, or even we estimate our runtime to be something around a year to process the data with our, for example, on-prem infrastructure, and how we can approach this problem, what strategies we should employ to minimize the compute resource wastage and maximize cost effectiveness in cloud-based omic analysis. So here, Geraldine, may I ask you to start this section?
Absolutely. Absolutely. Thank you, Camille. Yeah, so we already touched on some of this already in the first section, I think. So for me, the experience that I'm basing these comments on is witnessing the migration of the Broad's genomic pipeline from a legacy on-prem system with very bespoke workflow management to a cloud-native solution. And a lot of the lessons learned in that process, I think, are fairly universal to the questions that our viewers will probably be asking themselves. And we talked a little bit about already kind of the separation of concerns between the scientific workflow and kind of the plumbing of workflows. You really do have to think very differently about the implementation of the pipeline if you're going to go full cloud. And I would say some of the things that that we found in the process of that initial migration, and I should say this was probably 10 years ago, almost 10 years ago. We were really the first going to cloud with a big genomics workload. And so it was a lot of learning things from scratch at the time. And things like what Ankit already mentioned about how you group versus split jobs across VMs, that connects to the problem of allocating resources in a way that is fit for purpose. For every task, for every step in your pipeline, you have to understand the computational requirements really well. Understand that depending on the shape and size of the data and the kind of algorithm, the scientific algorithm that you're running, there are going to be certain computational requirements. In some cases, you might want a beefy VM with a lot of compute, a lot of memory. Sometimes you just, it's going to be a small operation that's just kind of cheap, but it's more disk bound. So there's some very different like shapes and sizes of machine that might be appropriate. And so you really want to right size the allocation, meaning for each step, allocate the right kind of machine with the right kind of configuration. And that's something where it can help because people often ask, well, how you know, what to do. One, it really helps if the author of those programs has documented that really well. Unfortunately, we know most of the time we can't count on that. So you have to do things like profiling, run it a bunch of times on as much data as possible. And also, data there's a lot of variability in omics data. We say a genome, what does that mean? Is it a 10x genome? Is it 50x in terms of coverage? There's a lot of different technologies now. There's a rebirth of sequencing technologies that have different kind of profiles. And so you need to know kind of for the types of data that you're going to be running, you want to run as many kind of test runs as possible, do a lot of profiling, and from that you can learn. And there are tools that can help with that, right? 10 years ago, there was much less. Since then, there's been kind of a flourishing ecosystem that has sprung up. You guys are part of it. And it's very helpful because ultimately you want to be able to, again, allocate the right kinds of machines and resources to each step. So those I would say are very universal approaches that are very helpful. And then there are some things that are a bit more vendor specific. We talked already about spot instances. Some other vendors call them preemptibles. The behavior isn't quite the same. So first, there's definitely you want to leverage spots, preemptibles, whatever they're called on your particular platform. And you want to understand what the different behaviors are. But it does lead to huge savings. And just to throw out a few numbers, when the original Broad's whole genome pipeline was migrated from on-prem to cloud, the initial completely naive implementation with no optimizations was about, I want to say $85 per whole genome. With some basic optimization, they very quickly brought that down to $45 per genome, which is like, oh, wow, it's almost half. That's fantastic. Well, another I want to say at the time, it took 3 to 6 months. Today, it would take much less because we have all these tools. But at the time, a little bit further investment took it down to $5 a genome. And if you think about the cost reduction there, that was huge. And nowadays, you can use that kind of those kinds of approaches. You don't have to do 6 months of R&D because a lot of the tools exist. But you can really make a really big difference from the naive implementation to an optimized implementation. Again, using those universal concepts of right sizing allocation, plus the vendor specific things like spot and preemptibles. But you have to understand the trade-offs. So if you choose to use something like spot instances that basically can be taken away from you at any point, you have to understand that the job is going to have to restart. Obviously, this is where some of you guys come in terms of mitigating that, right?
Yeah, and I know Jing has a lot to say on that regards. And so I'll reserve my comments on this, Jing, but I know this is where you have a very elegant solution.
Yeah, and I want to start by saying that it's not as if our solution and what we do is always the best first answer. There's a lot of different things that you can do to parallelize and shorten the pipelines that you have. And a lot of the folks here have many great things to share around how that can be done. But there is a trade-off, right? How many different optimizations you want to do to the pipeline? Does it make your results more accurate, or does it simply speed up the runtime of the pipeline? And the trade-offs to make those optimizations to the many pipelines that you're using, those are all real trade-offs, time, energy, and resources. One of the things that we do make it easier for someone to do is to run some pipelines which may simply need to run longer, or you don't have the time to go and make it run quicker or shorter, or for parallelize different parts of it. We can help essentially survive these spot interruptions through checkpoint and restore technology. And that's always something that's really nice to see customers be able to take advantage of. There are considerations even with that, though, across the different cloud providers. I would say if I were to compare, the top 3 today, AWS gives you the longest time to take care of your work, meaning that when your spot instance does get reclaimed, AWS gives you a 2-minute warning. You get a 2-minute head start to take care of work. And MemVerge solution is able to take advantage of that extra time that you have on AWS compared to other clouds, which give you about 30 seconds, which is only 1/4 the amount of time. Now, there are ways to essentially detect the state of your work before relying on the last warning, but those different things tend to cost, those different approaches tend to cost more money, because you're having to write things to disk. You're trying to write memory state to disk, and you're having to do that preemptively before you get the 2-minute warning. And so the main kind of takeaway is that you can save a much larger instance and a much larger workload without having to do anything before the preemption warning. if you are running on Spot instances from AWS compared to the other clouds. And it's not something that everyone always knows, so I like to share it. But in general, yeah, if you're going from on-demand and starting to use Spot, that's always the right first step.
Thanks, Tim. Thanks for sharing, and thanks for the AWS plug. We're very proud of our Spot service. I do want to add just a little bit of a color to that comment as well, right? I mean, yeah, I want folks that are on the call today to understand that Spot is sort of our spare capacity that now you can provide to the customers to be able to leverage at a highly optimized, cost-efficient way. But then at the same point, it's also, like I said, it's spare capacity, right? So not only can it be taken away from you, but when I was initially talking about getting access to the latest and greatest in instances, you might actually not get them on the spot. Like in today's world where Gen AI is the hype word everywhere, and everybody is trying to get Gen AI workloads, and NVIDIA stock is going through the roof. Try getting GPU instances on Spot. it's an extreme challenge, right? So what I want people to sort of also think about is, well, yeah, there's a lot of savings that you can achieve in instance costs, but between, let's say, Spot and on demand, availability and scalability are important considerations as well. And so at AWS, we like to think of it as the total cost of ownership, for your particular workload. And that also goes into thinking about things like, well, how often would I be able to get this particular savings? How often I'm going to be interrupted? How many samples would I run on a normal basis, and what my turnaround times are going to be, and all of those things are important considerations when you think about TCO analysis for your workloads. Geraldine.
Yeah, I just wanted to kind of jump on that. I think it ties into the idea of really understanding what trade-offs you're making and what's your priority. And I think we touched on that a little bit earlier. But for example, if you're running a production pipeline where you just need to keep it churning, but you don't need to have the results immediately, you can wait, you can deal with retries, you can deal with a number of things. You might also not necessarily need the latest and greatest hardware. However, if you're doing you're in an R&D activity, and the time of your developers is more expensive than the time of the machines, right? So you need to be able to have your developers progress very rapidly, be able to iterate extremely rapidly, because the cost of paying the humans who are operating the machines is higher, and also the cost, the opportunity cost of needing to find the solution faster than maybe your competitors. You need to be able to work and advance extremely quickly. You might need the latest and greatest in hardware, etc. And there, knowing what is your I want to say your business imperative, like what's more important, getting the answer fast, getting to a product fast, or do you have just something that's running in your background? The nice thing with a lot of this infrastructure is that you can do both. You can have two different kinds of activities, and you can have the same workflow in many cases. Once you can design it, implement it in a way that gives you a lot of flexibility, and especially with something with a workflow language, workflow framework like Nextflow, for a quick plug for that, you can have the plumbing be designed to be very flexible, so that you can separate the configuration of what kind of infrastructure you're going to run it on from the workflow itself, in the sense of what are the steps, the processing that needs to be done to the data, in what order, what scientific tools, etc., so that you can initially have something that runs very quickly, that you can iterate on very quickly through some just configuration files, a configuration profile that makes that run on a particular set, with a particular set of infrastructure requirements, specifications. But then once you've got something stable that you just want to run in production in background, you can shift just by making a new configuration and run with different infrastructure requirements. And then you don't have to re-engineer your workflow. You need to tweak the configuration, and you can take advantage kind of the different features. You can shift the trade-offs to what makes sense at the time. And I think that is something that didn't exist back when the world was young and dinosaurs roamed the earth, and we all had bespoke workflow management systems. But with the tools we have today, it's a lot easier to give yourself that flexibility. You just have to think about it kind of in the initial stages to make sure you build in that flexibility for yourself.
And I would say thank you to the teams that wrote it, that some of the pioneering work that the folks did over there in the initial years of genomics. I mean, I remember back in 2005, 2006, just thinking about how you can process this large amounts of genomics data. It was such a challenge, and now we have tools available to us. It's certainly come a long way, but there's certainly a lot to do.
Thank you for your comments. And here I give a little bit different perspective from my end, since my work is mainly focused on pipeline optimization. So the cases which we see, first, use workflow manager. It really helps, and it is like starting point for any pipeline. Very basic. Usually most popular nowadays are Nexo, WDO. Depending on the case, check which one is the best for you, because that's a starting point to be able to use cloud in like reasonable, manageable manner. Then check before migration, because nowadays, as Itai mentioned during his presentation on AWS reInvent, there is a NF Core community which provides a ton of very useful pipelines which serve as a very good starting point for most common bioinformatical workflows and data types which you may need to process. So start from them as a starting point and adapt to your needs. That would be second thought. And as Geraldine mentioned, check the resources assignment, because those may be over-provisioned, and good workflow managers allow you to allocate resources dynamically based on the sample size. So that is something what is very rarely used in industry. We usually assume that, well, we would like to support worst case always, and in the average cases we heavily over provision, and most of the tools, especially bio-oriented tools, are usually there's correlation, very clear correlation between input size and RAM usage. So you can control that and optimize this that way. And if you for some reason have job which there's no way to distribute and use spot instances, as Ankit mentioned, nowadays when everyone would like to switch to spot instances, then literally spot instance price will be equal to on-demand price, and well, there will be no saving. But we are not there yet. In some regions, you still may get some cost effectiveness, and then you can deploy Cloud solution to be able to continue this pipeline. And with that said, we have still one more topic to cover. So maybe Itai, you would like to close this part, and maybe you can give us a bit more comments regarding your experience with pipeline optimization.
Definitely. Thanks, Camille, and thanks to everyone for the comments so far. I definitely agree with everything that's been said about what you can do to optimize. One thing that I didn't hear explicitly mentioned for those who may not be familiar is the resume function in Nextflow. If you have a platform that enables that, absolutely, that's going to be great to be able to go back into your pipeline from wherever things stopped rather than having to start all over again, right? Another thing that Geraldine mentioned quite a bit is like right sizing of the appropriate EC2 instances, right? And if you have the time and the resources and the willpower, you may, as Geraldine suggested, be able to run a wide array of tests to really figure out what are the best sizes for each individual process within your pipeline. That is one way to do it. Sometimes you can also get away with just pulling things from NF Core and figuring out what have other people already figured out for you. As Camille mentioned, NF Core is a great resource. Other times, if neither of those is really going to work, as Camille also mentioned, you have the ability to do dynamic retry strategies. And this is something that I did not understand when I first started working with these pipelines, but it's tremendously helpful for optimizing and preventing you from having to crash out of the whole pipeline. And you can even set it such that a given task retries with a certain amount of CPU and a certain amount of memory based on the task attempt. So if it fails the first time, it doubles. And if it fails that time, it doubles. And then you probably want to set a limit because you don't want it to just keep going like that forever, obviously. But that can be a really useful way to optimize your cost and computational resource wastage. And then the other thing that I wanted to mention really briefly in relation to NF Core is that they usually provide you with some kind of minimal test data set. So this is another really important thing, I think, when you're thinking about how do I optimize my pipeline deployment and how do I know it works in the way that I expect it to, you should test it on a small, minimal set of test data. And as I said, NF Core usually provides that. If you're not using an NF Core, if you're doing something custom, which is also very common, try testing it on a small set of data first. That's a usually obvious thing, but you never know. Sometimes in an omics setting, you say, oh, I just want it to run. It'll just go. It doesn't usually work that way, unfortunately.
Yeah, I would like to add to the testing because smoke test is very important to ensure that your pipeline is still doing what you would like it to do. During development, various processes are added, various additional logic is being added, and very useful is to have a smoke test on somehow manageable data. To be able to validate your pipeline rapidly and have this development cycle within a minutes instead of hours to be able to complete this development cycle. Thank you for this part. And with that, I would like to continue to the next section, which is balance between developers' experience and business challenges. Here, I believe we already mentioned a few of those, but let's continue. How different it is to run Omics pipeline on-prem versus in the cloud. I already mentioned a few differences, but let's continue. What are some technical considerations when moving to the cloud? What are some business and commercial considerations? And here, Ankit, feel free to start this part.
Yeah, I feel like that has been sort of the crux of the discussion so far already. We have already discussed a little bit on what are the technical challenges when you getting started in the cloud and what are sort of the business challenges. It's all about trying to find that right balance between, right, like the Geraldine and Itai have mentioned about how soon do you want to be able to run your workflows and how tolerant you are of, for example, retries. What is your developer experience like? So I had somebody ask me yesterday, right? And then the question they asked was, well, can you give me a recommendation for what is the best workflow management language that's out there? Now, Geraldine, and I completely agree, given the community around it, Nextflow might be or is probably the best or most adopted workflow manager out there. But if you think of it from a business perspective, the best workflow management solution is what your developer community internally is already used to. Because what you don't want to do is go and retrain your developer community for a different workflow management solution, right? You can move them along, but when you're trying to balance your business considerations, it's something to think about. If I was starting fresh, completely like training a student, I would 100% tell them, right? Go use Nextflow. It's the most widely adopted. You find the best community out there, and then you have solutions like Seqera is developing, which will solve a lot of challenges, right? It's also something that, for example, we support through Health Omics. at AWS, and when we were thinking about investments in this space. So that's certainly a consideration. One of the considerations when you're trying to balance between how soon you want to get started, how quickly you want to get started, like scale what you're doing versus how much time do you want to spend on building stuff. Um, One thing, I mean, I think at AWS, and back to Geraldine, your comment, I know there's a lot of similarities between clouds. One thing that we at AWS like to do is what we call our working backwards process, right? In which every year we sort of work with our customers who are using the AWS cloud and try to understand what are the challenges that they are having and how we can sort of help them solve those. And so we applied the working backwards process to the genomics community and the healthcare community, like about 3 or 4 years when we started to realize this is a completely new vertical of its own. And sort of we started thinking about what are the challenges, right? What are the foundational challenges that the industry is facing? Genomics as an industry is a massive industry. You have researchers, you have nonprofit organizations, you have public health, you have life sciences organizations, you have pharma, biotech, and you're serving the entire industry. The foundational challenge was still around data management, right? And something that we actually haven't discussed today. Something we have discussed today, the other foundational challenge was how do you do workflows at scale and improve the developer experience? And finally, how do you now start to connect what you have done with secondary analysis and be able to run insight generation on it, right? How do you pull the data in various ways? And sort of that was the central thesis behind our investments in the space. So while AWS provides a lot of Lego blocks, Batch, EC2, S3, we have started to build specialized Lego blocks to a certain extent. And that's where we provide these specialized Lego blocks like Health Omics and Health Imaging, Health Scribe, and Health Lake, our Health AI suite of services for partners to build with, to provide solutions on top of it. So if you have a challenge around what is the best way of storing genomics data in the cloud, I would say the answer is Health Omics, because we, as a cloud service provider, as a hyperscaler, we take on the challenge of figuring out how do you best store genomics data, CRAMs, PAMs, FASTQs, to get it most performant and most cost efficient to the end customers. So
Yeah.
Sorry, go ahead.
No, I was just going to jump in and agree that's the connection to data management and also the downstream insight generation is critical, because for a long time bioinformatics pipelines have been treated sort of in isolation as a thing that starts with the pipeline and ends with the pipeline. But the reality is that on one hand, you connect to the data generation in the lab. So you need to plug into a LIMS system. You need to integrate that and data management and so on. And you have project managers who have to be able to manage data, etc. And then on the other side, you have so then you have bioinformaticians who need to connect that, get the pipelines to run on that data that's in storage. But then on the kind of downstream, once you have the outputs of the pipeline, often people need to work interactively with the data that's outputs. There's still more analysis to do. That's often done in interactive ways through various types of interfaces by people who might be the same people, but might be different people who are further down, who are a different background and experience. Sometimes people say more or less technical. I don't think it's a question of being more or less technical. It's just having a specialty that's in kind of the next stage, and using, and the rise of things like notebooks, like Jupyter Notebooks, RStudio, those kinds of apps, and some more domain specialized apps as well, for doing the interactive analysis. The connections between those three phases is really important. I mean, that's something we're tackling at Seqera with Seqera Platform, right, which offers which seeks to offer the data management piece, the workflow. Obviously, the workflow execution piece is the one we're most well known for, and then the interactive experience through data studios, which is something we'll be talking about more later this year. And can I make a quick plug for the Boston Summit. We have our next Flow Summit coming up in Boston in May. And we hope to see many of you there. We'll be talking about some of this. The integration of those 3 phases of analysis, I think, is really critical. And doing that in a way that suits the particular tooling and concerns of the researchers who are going to be the ones doing the work at the keyboard.
Thank you.
Plus one for the Boston Summit. I was there for last year's summit. It's an excellent community, developer community that comes together. Not only do we do a hackathon, but we also share the best practices and some amazing stories. So plus one, be there.
We will be there. We will be there, Ankit. I believe we hope that many persons will be there too. Definitely very, very good opportunity to interact with the community and exchange the ideas. I would like to comment, Ankit, a bit more on one item which you mentioned, the selection of the workflow management system, because I only partially agree with your comment. If you have modern workflow management system deployed in your company, use it. But if you are still using a workflow management system which was never meant to be running efficiently on cloud, invest and check what will be your best fit.
No, 100%, 100%. I think my question was, what is the best workflow management solution out there? Well, the one that you have in your company. But yeah, 100% agree. If you can utilize workflow management solutions, definitely 100%. That's the way to go.
And one additional remark regarding Health Omics. Well, I've used it, I tested, and I played with it, and I like it. But there's one thing which, as a developer, find a bit challenging, is that, well, this is one additional layer at the top of the Nextflow pipeline. So when we are doing a development, let's say we have this small data set which we can run on our work station, then it is a bit tricky from time to time to ensure that the deployment will be smooth and will have exactly the same setup in Health Omics. So this is one thing which is worth to remember, that this is one additional layer at the top of your workflow manager, and useful, allowing you to get rid of the old infrastructure under the hood and be focused on the data and the analysis. But this is one thing which is worth to remember. And well,
certainly, and just to add on to that, I mean, 2 points, and I'll actually send it back to Geraldine to address this from an NFTower perspective as well. But just 2 points, right? I mean, Health Omics is relatively new. I mean, we launched it at reInvent 2022, so November 2022, and we are continuously making improvements to the service, bringing more and more features. Like just in the last year, we have launched Ready to Run, we have launched cross-account sharing, we have launched FedRAMP support within the service, just to name a few, right? So we're constantly trying to improve the developer experience. It's the thesis is to simplify execution of workflows, not to add an additional layer. So it's an abstraction on top of workflow management solution that will our partners and customers can sort of both rely on it. But there are other solutions in the market, right? I mean, if you think about it, that's one of the central challenges that NFTower, Seqera's NFTower solution also helps address. And we at AWS, it's all about customer choice. So when we have things like Health Omics, it's not supposed to be a replacement for something like NFTower. It's sort of a complementary approach, so that when customers have a need, they have choices.
You're right. I fully agree with you. This is what I meant. Like, this is like additional layer to simplify the cloud experience. That's how I interpret this. And well, we have 1 minute remaining, and well, we mentioned that there will be Q&A session, but chat was very live, and everyone have been discussing there, and we've been commenting there. So Itai, maybe last comment in this section from you to address your point of view as a AWS Health Omics user, and maybe you can give us some comments.
Sure. Yeah, thanks, Camille. So just going back to the question initially, how different is it to run Omics pipelines on-prem versus in the cloud? I'd say pretty different. In terms of the hurdles that you have to overcome that I think of immediately is getting all the necessary tools in place in an on-prem setting. They might all live in a centralized managed file system, and that's really easy to draw from. But obviously, we've discussed a little bit about containerization here. I just want to emphasize how important that is, regardless of what commands you think you're doing. Even a simple Unix command like a cut or an awk could have slightly different outcomes depending on the Linux distribution that you're using, if it's Ubuntu, Fedora, Red Hat, what have you. So in a cloud setting, again, containers to isolate, silo, and control the compute setting is really crucial. I have the most experience using Docker, but that's not the only tool for that, obviously. The input files is also another potential headache. Solutions like S3 or FSX for Lustre can really help you out with that. Other technical considerations that you may not have had to make in an on-prem paradigm that we've discussed a little bit include right sizing of the machines and use of concurrent CPUs and memories, sufficient space to store the outputs, data security, authorization, and scalability. And that last one really benefits from the cloud setting, right? Because if you hit a hardware limit on your own on-prem cluster, you're kind of done until you buy new hardware. But in a cloud setting, obviously, you can leverage service providers like AWS and others who are able to give you that new hardware without you having to pay for it, right? So yeah, and then thinking about it a little bit, I'll close out by thinking a little bit from like the business commercial perspective about on-prem versus cloud-based, right? Is that when you're doing on-prem, that's basically representing an operational, or excuse me, a capital expenditure, right? Because you have to buy all the hardware and you have to refresh it. When you go to the cloud, that's more of a usage expenditure, right? So it's kind of as you go, you're paying. And so I think like it makes sense, and we're probably all in agreement that moving to the cloud over time is going to make a lot more sense. And yeah, as Camille mentioned, I've primarily used Health Omics. And you're not gonna get me to say anything bad about it. I've enjoyed it a lot, but there's definitely places to improve. And I will say AWS has been really great with Amgen going back and forth in the development process. Yeah, so once again, that's kind of all I had. I really thank everyone for their time and their comments. It was really insightful for me.
Thank you very much. Thank you all for this meeting. And well, we'll skip Q&A session because we ran out of time, but discussion was very, very promising and interesting. If you find any interest, if you would like to ask your questions, or if you would like to touch base with us later, here you have our emails. And well, we will be more than happy to answer any questions which you may still have offline. So thank you very much once again, Geraldine, Itai, Ankit, for your time and willingness to share your experience with us. And well, I hope that we'll have chance to see in future, maybe during Nexus Summit.
Yeah, I mean, and just to leave one last plug, we are going to be at the BioIT conference in Boston as well, and there might be some announcements. So folks should definitely look to attend BioIT and keep your ears closed. Ready to Run was launched at BioIT last year, so let's see what else we cook up.
You built up the curiosity in the best possible way, Ankit. And well, we as from Ardigen, we will be there too, and I believe
we will as well.
MemVerge will be there too, and Seqera will be there too. So if you are from
will be there.
Yeah, feel free to attend BioIT and speak with us in person.
Thanks, everyone.
Thank you.